Welcome to this tutorial on using MassFX in order to export animation data to Unreal Engine 4. Here's a quick animation just to demonstrate the kind of thing you can do inside of MassFX. It might seem, one question that you might have is, why on earth would you actually want to use an external physics simulator when you can just use Unreal Engine's physics simulation in real time? There are many reasons, the most obvious of which is that you might have a very expensive physics simulation that you want to use on a fairly trivial asset, which is the case here. This could be used, for example, in a cinematic scene where you want a very specific thing to occur. You want the chandelier to be destroyed in a very specific way. You want it to be predictable, and it's for a cutscene, so it has to be choreographed. So yeah, that's one of the reasons. Yeah, okay, fair enough. Let's move on. Let's move on. So create a fresh scene inside of 3ds Max. I've just realized I closed my notes. What am I doing? And we want to create a torus. A chandelier will be too complex for the scope of this tutorial. So instead of creating a chandelier, let's just make a chain. Go into the front or left hand viewport and go to Create Torus. Open keyboard entry, and we want major radius to be 32, radius 2 or minor radius to be 6, segments 32, sides 8, and press Create. Great. You may want to have your home grid synchronized with mine, so I have grid spacing set to 2, major lines every nth grid line set to 10. Now let's convert our torus into an editable poly. Press 4 and now select the bottommost faces. Press 2 to go into edge mode, and we now want to extrude faces downwards to create the length of our chain link. So with snaps toggle set to on, let's bring it down by 2 increments. Now go to Effect Pivot Only in the Hierarchy panel and bring the pivot point down to reflect the midpoint of the chain. Down at the bottom in the Transform dialog, I'm going to set the Z value to 0 so that we have the chain link in the center of the scene. Apply a symmetry modifier, where is it? On the y-axis, and collapse. Great. Okay, now I'm just going to simply apply a gray material just so that the chain link isn't distracting. Give it a black wireframe. Applying auto smooth so that things look nice. Great. Okay, so now we have our chain link. Let's give it a name that reflects its nature. So chainlink underscore mesh, and then the suffix 001. And this can be the main chain link, the root chain link as such. One thing that I forgot to point out beforehand, which I will cover now, is that basically Unreal Engine 4 only supports, although they're working on vertex animation, It's on the roadmap. Unreal Engine 4 only supports skeletal animation at the present time. So this chandelier that I showed you previously has a skin modifier applied to it, and we actually have this bone set up here, and it is these bones or dummies that are dictating the 3D transform values of the mesh. It's a single piece of geometry, or it's a single mesh object. Right, so let's go back. That means that we want to create a dummy in our scene. So go to create helpers dummy. What it also means is that we want all of the physics simulation to occur or to act upon the dummy rather than the chainlink, rather than the mesh, the torus. But obviously we want to use a collision mesh that derives from the torus rather than the dummy. We want the collisions to be calculated for a chainlink shape rather than a cube. So what we're going to do is, or what we're going to do first is name the dummy chainlink bone 001. And we want to set up a child-parent relationship such that the mesh is a child to the bone. In 3ds Max 2015, you can achieve this by clicking the icon over here and dragging it onto the bone icon, or the dummy icon, and it establishes the relationship. However, I think that in earlier versions of Max, this window, this panel isn't available, or you have to set it up manually. So another just as straightforward way of setting up the relationship is to go to Select and Link, click and drag from the child to the parent, and it establishes the relationship. Great. So now, just to confirm that, when we move the dummy, we can see that the mesh also moves. Select both objects, and you want to bring up the MassFX toolbar. So you right click in the main toolbar and it's an option available to you. You can then dock it wherever you like. So you can have it here, you can have it here. Personally, I like it up here. Go to set selected as dynamic rigid body, and yeah. Great. So now both objects have MassFX rigid body modifiers. Ultimately, we only want the bone to have the rigid body modifier, but we want to generate a collision mesh of the torus shape. So go to the modify panel and scroll down to shape type and select concave. Due to the complexity of this shape, we need to have a concave collision mesh. Select improve fitting and then press generate, and we have a collision mesh. Now select copy shape, and we want to copy the shape onto the bones, into the physical shapes available for the bone. So paste shape. Now we want to delete the collision mesh that was native to the bone, so delete, and we have this. So you may recall that earlier we moved the chain link up. Sorry, no, what did we do? I think it was -40, and we moved it up to 0. So essentially we moved it by 40 units. So what we want to do now is, if you expand the MassFX rigid body modifier, go to Mesh Transform. Now, if you right click on Select and Move, this isn't the only way to do it, but personally this is how I do it, how I like to do it, and go to Offset World Z, type in 40. and we should have it aligned. If you have been following this tutorial quite loosely, which is perfectly fine, I mean that's what I tend to do personally, you may just want to use the transform gizmo in order to position it appropriately. It's up to you. Great, okay, so now we have a bone with the collision mesh of a chain link. Select the mesh, the chain link mesh, and delete its rigid body as it's no longer needed. If we go to multi-object editor, and then the first tab, world parameters, we want to turn use ground collisions off. We want to turn substeps and solver iterations up. So I would recommend a minimum of 64 for substeps, and let's say 160 for solver iterations. If you have a graphics card and a CPU that supports multi-threading, in the engine section, select these two options. Right, so now if we play that animation, the simulation, by pressing this button here, we should see the chain link fall down, which we do. Great. I've decided that this chain is a bit thin. In order to remedy that, we have to fiddle around a tiny bit. So apply a push modifier to the geometry. Let's try 4. No, okay, 2. Yeah, 2.5. Okay. So a push value of 2.5, collapse. Then select. Okay. Then we want to reapply dynamic rigid body. Concave. Group it in, generate, and once again we want to copy. Let's delete the modifier now. So we're going to the bone and we're going to paste the shape, delete the one that preceded it, and again we need to reposition, so I'm just going to type in a value of 40. Perfect. Okay, now we can move on. So the next step is to go to Tools, Array. And we want to use instance as the object type, and I think around, let's say 12. Let's have 12 chain links, so count 12. Press preview, and we want the Z move increment to be around minus 125. And the Z rotate increment to be around, no, not around, it has to be exactly 90. Press OK. It's important to make sure that the collision meshes aren't overlapping, or we'll get odd behavior in the simulation. So let's just confirm that now. It looks like we might just about be okay. Let's run the simulation to find out. Yeah, okay, so the chains just fall, which confirms that everything is set up fine. Obviously, this is quite a boring setup as it currently is. Just having the chains fall isn't exactly the most interesting dynamic. So what we can do here is select the topmost chain, chain link bone 001, and if you right click on dummy, you want to say make unique, because the rest are instances of one another. Whereas you want to modify this one so that it is static, and therefore it must be unique. Go to rigid body type, and where it says dynamic, select static. Now if we run the simulation, we should see that the chains do not fall, but just simply jiggle around due to gravity. before I forget, this is a very important stage. We need to define a root. So let's create one final dummy at the very top of the chain. And let's call it chainlink root. Now we want to, if we just hide the geometry quickly, we want all of the other bones to be a child of chainlink root. Good. Now we can bring the geometry back. Sorry, by the way, in case you don't know, to hide geometry, you can press Shift G, and in order to hide helpers, you can press Shift H. It's very useful. And then, of course, there's also Alt. If you make a selection, there's Alt Q to isolate your selection. Great, okay. Now we want to apply a force in order to create a more interesting simulation. So go to Create, Space Warps, and we're going to apply a push, which is an impulse. It's just an impulse, along a vector. So, yeah, the idea here is that I basically want to create the impression of someone pushing against the chain link, as if it's just being brushed against. You know, it's hanging up somewhere and someone has kind of walked into it. That kind of thing, that kind of dynamic. Again, let's bear in mind that we have this instance relationship set up here. So if we want to give any of the bones any unique properties, we need to make them unique first. So I only want the push force to be applied to the bottom freemost chain links. So I'm going to make them unique. Be sure that you're selecting the bones and not the meshes. It's very easy to select the meshes by mistake, as it's the intuitive thing to select. Select the three bottommost bones, click on Dummy, and select Make Unique. You should be asked, do you want to make selected items unique with respect to each other? To which you reply no, because we want them to share the same properties with one another, but not with the other instances. So select no. One other thing that we forgot to do previously, that I will do now, is apply a physical material preset. So these are parameters that define the physical traits of your rigid body, such as its mass and bounciness. So we're going to use steel in this case, so select steel. Now remember that the bottom three most chain links share properties, but then if you scroll up, you've got a different instance relationship in the middle section, so you need to again apply it. And then the topmost chain link is unique as well, so we need to apply this preset to 3 of the bones. Great, okay. Before I did that, I was going to apply the push to the 3 bottommost bones. So you simply scroll down to forces and then you add push. And now these 3 bottom chain links will be affected by push. If we select push and go into its modifier panel, we want on time to be 0. Let's say 6 for off time. Let's use newtons, and let's try 10 million newtons. Let's see, so press play. So it's not strong enough. Let's try 100 million newtons. Yeah, okay, that's a lot nicer. This looks pretty cool. I mean, if you want to do something entirely different, please do. There's no reason that you have to follow this. It's just the general principle that I'm trying to kind of convey here. So if you want to do your own simulation with different forces, different parameters and so forth, please do. Right, okay, so we have our simulation set up. Although that looks pretty weird. That does look a bit odd. So I'm going to have on time 0, off time 2. That should probably be better. Yeah, I mean, this is okay. This is all right. We now want to bake animation. So go up to the MassFX toolbar, select Multi-Object Editor, and in Simulation Tools, you can specify that you want to bake all. Before you do this, make sure that in time configuration, you have the start time and the end time set to appropriate values. Now, in many cases, you will want an animation that loops. We're not going to cover that in this tutorial. If you want to clean up the animation so that it loops, you will have to either do that of your own accord, already knowing how to do it, or look it up. But there are many tutorials that cover that kind of thing, so it shouldn't be too difficult. I'm going to have the start time set to 0 and the end time set to 600. With that specified, I'm now going to press bake. And depending upon your setup, how complex the simulation is, how many render iterations there are, and various other factors, this could take a long time, or as is the case here, it could be fairly quick. Now is a good time to make some tea. Awesome. Okay, so it's finished. Now to confirm that, let's press play animation. Beautiful. Another thing to bear in mind is that the animation does actually seem to be quite slow, almost as if it's in slow motion. So you may want to speed it up. But again, that is beyond the scope of this tutorial. We no longer need the force or any of the simulation modifiers. So let's select, again, let's bear in mind that we have some instances here. So we want to select the top bone, delete the modifier, bottom bone, delete the modifier, and then one of the middle bones. Whoops. Delete modifier. Awesome, okay. Now we want to unparent the geometry from the bones. The only reason that we established this parent-child relationship was in order to visualize what the chain link animation would look like. Without it, we would just see a load of dummies moving like this. Which is interesting, I mean, it looks pretty cool, but we need to actually see the geometry, so that's why we did that. But now we can unparent the geometry. So Shift H to hide the helpers, and now select all of the geometry and go to Unlink Selection. Now bring the helpers back into the scene. No, don't bring them back. Okay, hide the helpers, select the topmost chain, select all of the chains. We want to convert the geometry from instances to unique geometry now. So one very quick way to do this is to right-click, convert all, convert to editable poly. Now they're all unique. Now if we select the topmost chain and go to the attach list, you can select all of the geometry and attach it so that we now only have one mesh containing all of the chain links. Remove the suffix 001 so that it's just chainlink mesh. And we're ready, if we bring the helpers back, to apply a skin modifier. And this is what will actually animate the, or should I say deform, the mesh in Unreal Engine. So first things first, you apply the modifier, go to Bones, Add, and you want to select all of the bones. Now select Edit Envelopes at the top, select Vertices, deselect Envelopes and Cross Sections. Make sure that Select Element is on. Then you want the Weight tool open. This is how we will assign weights to the vertices. In Display, we can leave Show Colored Vertices on, but uncheck the other options. Down here in Advanced Parameters, we want Rigid Vertices all to be selected. This will stop soft deformation from occurring so that the whole chain links are deformed rather than just sections of them softly being deformed. Go to Select Chainlink Root. Now let's select all vertices in the scene and press 1 so that all vertices in the scene are assigned to Chainlink Root. Now we want to go along the hierarchy, bone by bone, assigning vertices to their corresponding bone. This should be relatively straightforward and should take no longer than about 30 seconds. And if you have a nice, if you have named your bones well so that the order is correct, it should be very pain-free. I mean, if you have like a very complex setup, this could be a bit enduring, a bit laborious. This isn't too bad. Almost done. Great, okay, so now let's preview the animation and ensure that it works, which it does. Great, okay, so this is pretty much ready to go into Unreal Engine. The lack of speed is actually annoying me, to be honest. So I'm going to select everything in the scene, go to the Graph Editors menu, select Curve Editor, then zoom out. I want to select all of the keys, and let's see, Edit, Transform Tools, Scale Keys tool. Now if you click at the very end of the animation, you can drag the animation along. So let's make it so it's 75% of its original length, or let's 70. Great, and now let's see where the animation cuts out. So again, you may want to deviate from the tutorial here. It's up to you. 420. So in time configuration, let's set the end time to 420. And now we have a slightly more natural motion, although it's still quite slow. You could just say these are really heavy chains, and then it makes sense. Right, okay, so Control A, go up to the Max menu, and select export, export selection. Name it whatever you want and use whatever kind of file system taxonomy that you are using. Not taxonomy, you know what I mean. You can use whatever convention you want to use. Make sure it's an FBX, and that when you go into the FBX export options, you have FBX 2014 selected. Another importance is that animation is selected. And although there's no reason to do this, I have decided to bake the animation. You don't need to do this, I just decided that I wanted to do it to make sure that everything is clean. Press OK, export, and now let's go into UDK. Unreal Engine 4. UDK is now archaic. Go to the content browser, right-click, import, navigate to your FBX. And in the import options, make sure that import as skeletal is checked, and import animations is checked. Great, okay, that should work. Okay, and now over here, let's just specify that we want the animation to start up. So use animation asset. Now click and drag. This is just for previewing the final animation to confirm that it works. So animation anim to play. And now hopefully, yay! Look, it's working. So here is an example of how to get very natural, realistic physics simulation into Unreal Engine 4 without wasting any simulation resources by simulating in real time. I hope my tutorial has been informative and has helped you. If you have any questions, please be sure to contact me. Thanks for watching my tutorial. Bye.